Hello, everybody. We are going to do lesson 9.1 today, which is on adding and subtracting rational expressions. Before we start the notes in your book, I'd like you to try these two warm-up problems just to kind of refresh your memory back to middle school on how to add and subtract fractions. So go ahead and pause your video and try these two problems, A and B, by finding a common denominator and adding them together. So the common denominator for problem A is 15. That's a number that both 5 and 3 divide into evenly. And so to make those denominators both 15, we would have to multiply the numerator and denominator by the same number to get the 15 in the bottom. So this is to get 15 in the bottom, we would need to multiply by 5 over 5. So because 5 over 5 is just 1, and so that doesn't change the value of this fraction. It changes it to 5/15, which is equal to 1/3. Okay, and then to make this one into a 15 in the bottom, we'd have to multiply by 3 over 3. So that gives us 6 over 15. And now that we have the same denominator, we add the tops, get 11. The denominator stays the same. Okay, and then the same general process for problem B. The least common denominator for 12 and 8 is 24. Both of those numbers divide evenly into 24. So this one we would have to multiply by 2 over 2 to get 24 in the bottom. That gives us 10 24ths. And this one we would have to multiply by 3 over 3 to get 9 24ths. And so our answer then is 19 24ths. Okay, so the reason why I had you do these two examples is because we're going to do exactly the same thing, but with rational expressions involving variables, not just numbers. So we really need to understand how addition and subtraction of fractions with numbers works in order to better understand adding and subtracting rational expressions. Okay, and so then go ahead and open up your books to page 427. And we'll work on a couple examples here. So first we're just going to focus on finding the least common denominator. And so they say in this box here that if you factor each denominator, write any repeated factors as powers, we want to list the different factors. And if the denominators have common factors, then we use the highest power of each common factor. Okay, so in this first example A, the first step is to factor the denominators. So when you factor this denominator, you get 3x minus 5. When you factor this denominator, you get 4 times x plus 7. Okay, and so if we list all of the different factors, that's what they did here. The different factors are 3 and 4 and x minus 5 and x plus 7. Those are all different, so they all have to appear in our least common denominator. And so if you list all those factors and then multiply them like this, you end up with our least common denominator of 12 times x minus 5 times x plus 7. Okay, in example B, we're going to go through the same process. So to factor this denominator, we would have x minus 3 times x minus 8. And to factor this denominator, we would have, let's see, if we do x minus 3 times x minus 3. And the different factors are only x minus 3 and x minus 8. Okay, so this one has x minus 3 squared, whereas this one only has x minus 3 to the first power. So we take the highest power. So taking the highest power of x minus 3, we get x minus 3 squared times x minus 8. Okay, so anytime there's a repeated factor like we have here, we take the highest power that we see, which is 2. Okay, now I would like you to try problem 5. So pause your video, factor the denominators, see if you can come up with your least common denominator. Press play when you're ready to see the solution. So if we factor this first denominator, we would have 8 times x minus 3. And factor the second denominator, we have 10 times x minus 3. And so we see that if we list all of our different denominators, actually, if we factor the 8 and the 10, this is 2 cubed times x minus 3. And then this is 2 times 5 times x minus 3. That'll help to find our least common denominator. So our least common denominator is going to have, so our factors are 2, 5, and x minus 3. And so our least common denominator then is 2 cubed times times 5. 2 cubed is because the highest power that we see is 3, times 5 times x minus 3. And so that is 40 times x minus 3. Another way to get 40 is to just look at what is the least common denominator for 8 and 10, and that is 40. Okay, so 40 times x minus 3 is our least common denominator. All right, I'd like you to try one more. Try example 6. So pause your video and then press play when you're ready to see the solution. Okay, so this first denominator is 15 times x plus 4, and the second denominator is x plus 4 times x plus 5. And so our different denominators, 15 is 3 times 5, and x plus 4. So we have 3, 5, x plus 4, and x plus 5. Those are our different factors. None of them are repeated. Well, x plus 4 is repeated, but the highest power we see is first power. So our common denominator is going to be 15, x plus 4, x plus 5. So now when we get to adding and subtracting rational expressions, we need to find the least common denominator, just like we did in the warm-up today, in order to add the expressions. So in this first example, we have these denominators. If we factor them, they look like this. So the least common denominator is x squared, x plus 1. And so to get that, we would multiply the first expression by x plus 1 on the top and the bottom, and the second expression by x over x to get that least common multiple. Now that we have now that they both have the same denominator here and here, we can just add what's on top. And so when we add x cubed to x cubed, we get 2x cubed, and then plus the rest of this step. Okay, so let's do the next example together. We don't necessarily have to follow their work here. Let's just do it together over on the side. So this first denominator is x times x minus 5, and the second denominator is x squared. So our LCD is going to be x squared, x minus 5. And so if I take the first fraction, that is 2x squared times x minus 5, we want it to have a denominator of x squared, x minus 5. So this is the most important step here, is to figure out how we get that least common denominator. This second fraction has only an x squared. And we want it to be x squared, x minus 5. Okay, so what we need to do is figure out what fraction should I multiply this by to get this new denominator. Okay, and notice that these two denominators almost look the same. The only difference is this one is an x and this one is an x squared. So that means we're going to need another x. If we multiply by x, then we'll have the denominator that we want. So I have to do the same thing on the top and the bottom. So now this is going to become 2x cubed over x squared x minus 5. Okay, and now let's look at the second fraction. We want to get from this denominator to this denominator. Well, what's missing? What's missing is an x minus 5. And so we need to multiply by that on the top and the bottom. So now I have x squared plus 3x minus 4 times x minus 5 on the top. And now we're ready to add these together. Actually, before we do that, we should do this multiplication. And so to multiply those expressions, I'm going to set up a grid, do the grid method. So we have x minus 5 times x squared plus 3x minus 4. And so that is x cubed, 3x squared minus 4x minus 5x squared minus 15x plus 20. And so when we add those, we get x cubed. Add these together, that's minus 2x squared. Add these together, that's minus 19x, and then plus 20. Okay, so that means we're adding 2x cubed. Let's put it all over one denominator. So we have 2x cubed plus x cubed minus 2x squared minus 19x plus 20 over x squared x minus 5. And these two terms can add together to get our final answer of 3x cubed minus 2x squared minus 19x plus 20 over x squared x minus 5. Realized looking at the original problem, this was actually a subtraction problem, so we can easily fix that in our answer. This should have been a minus sign, so we'll just go through and change this to minus signs. So now it's going to be subtracting that answer that we got from this long division or long multiplication over here. And so that becomes 2x cubed minus we're subtracting this. Okay, so 2x cubed minus x cubed gives us just 1x cubed, and then it's going to be plus 2x squared plus 19x and minus 20. And so that now is the correct answer. I just had done addition instead of subtraction. Okay, so going on to the next page, I would like you to pause your video and try number 7. Press play when you're ready to see the solution. Okay, so for number 7, we have negative x squared over 1, and let's see, add each pair of expressions. So when we add those, we get 1 over 1 minus x squared. And so this will become our new denominator. So to make our denominator 1 minus x squared, we have to multiply the top and the bottom of this by 1 minus x squared. And so then that gives us negative x squared plus x to the 4th. And then this one stays the same. And now when we add those, we have x to the 4th minus x squared plus 1 over 1 minus x squared. And then it also says subtract the second expression from the first. So if we subtract this time instead of add, so if we subtract, we have negative x squared plus x to the 4th over 1 minus x squared minus 1 over 1 minus x squared. So the denominators are still the same. We're just going to end up now with x to the 4th minus x squared minus 1 this time, where it was plus 1 before, over 1 minus x squared. So that this is what we get when we do the addition, and this is so this is the addition, and this is what we get when we do the subtraction. Okay, so now go ahead and instead of doing problem 8, I'm going to have you try a problem that I created as an example. Okay, so let's try this example B. So go ahead and copy that down. If you have some extra space in your book, you can squeeze it in there, or if you want to take out a piece of binder paper, copy that one down and try example B. Pause your video and then press play when you're ready to see the solution. So the first expression factored is 2 times 5 times x, and or x squared, and then this is going to be 2x and factor out a 5x times x minus 2. And so from this we can see that our common denominator is going to have 2, 5, x squared, and x minus 2. Okay, and so to get that common denominator, we would have to multiply this one by, let's see, what's missing. We have all of this here already, so the only thing that's missing is the x minus 2. So we're going to have to multiply the top and the bottom by x minus 2. So that gives us 3x minus 6 on the top. And then if we compare these denominators, we want to see what's missing. So we need a 2. And we need another x. And so we're going to multiply the top and the bottom by 2x. So that gives us 4x squared. And now when we add the top and the bottom, we have now 4x squared plus 3x minus 6 over 10x squared times x minus 2. Okay, and one more for you to try. Last problem for today. Try problem C. Copy that one down in any blank area that you have. Pause your video, and then press play when you're ready to see the solution. Okay, so if you factor this denominator, that's 3 times x minus 5. And let's see what we have up here. We have x minus 5 times x plus 1. And so our common denominator then is going to be 3 x minus 5 x minus 1. Okay, and so what we're going to multiply by on the top and the bottom for this problem is we need an x minus 1 on the top and the bottom to make that common denominator. So that's going to give us x squared minus x. Oh, actually, I just realized something here, that in this original problem we could cancel those. If you didn't recognize that, then you could use this common denominator. Those were both x plus 1s, not minus 1s anyway. Okay, so let's so if we're going to cancel those, then we see that our common denominator is actually just 3 times x minus 5 for both. Okay, and so this one is fine the way it is. This one I would have to multiply by 3 on the top and the bottom, so that gives me 6. And so our final answer then is x minus 6 over 3 times x minus 5. And that's it for today's lesson. Have a great day.